In this video, we're going to explore the topic of system of inequalities. So before we get started, why don't you take a look at the warm-up and see if you can come up with the answer. After you're done, unpause the video to see if you were right. So in this warm-up, it is asking you to take each of these equations, so 1 and then 2, and match them with the correct solution and graph. So in the first problem, if you took this, you'd have 2x plus 5 is less than 19. You subtract 5, you get 2x is less than 14. And then after you divide by 2, you get x is less than 7. So you can see that the correct way to represent the solution would be B, when it says x is less than 7, with the open circle next to the 7 and shaded to the left. And then the type of answer it will be is a set of numbers. We know it's going to be a set of numbers because an ordered pair has x and a y value, and we know that this equation does not have any y values. So the correct answer for number 1 is the solution B and or the graph B and the solution D. That leaves A and C for number 2. Now this is actually a system of linear inequalities, which is what we're going to talk about today in terms of solving them and finding their solution. So what you can see here is you'll notice that on the graph A, you can see that both of these inequalities are graphed, and that you can see there is a place on the graph where the two shaded regions for these lines or these inequalities intersect. So we're going to talk about what that means. Now, in terms of the type of solutions that this is going to have, there's an x variable and a y variable. That means that the solution is going to be the set of x and y values that satisfy both of these inequalities at the same time. So what we're going to look at now is we're going to move into looking at what a system of inequalities is. Like a system of equations, a system of inequalities is where you have two or more inequalities where you're looking to find the xy coordinates that satisfy both inequalities at the same time. So we're going to take a look first at how to graph a system of inequalities and find the solution. And then we're going to look at a couple problems where we have to set up the system of inequalities based off of a word problem. When we're solving these word problems, you're going to need to write the inequalities, and these inequalities that you're writing are called constraints. After you write the inequalities, you graph them, and you're going to find a region instead of a single point that represents all the solutions. So let's take a look at this first example. We have the system of inequalities. Y is less than or equal to negative 2 plus 3 halves x, and y is greater than 1 minus x. We're going to graph the boundary lines for each of these and shade the correct region that represents the solution for each of these inequalities. So first we'll look at y is less than or equal to negative 2 plus 3 halves x. The y-intercept is negative 2, and then you're going to go up 3 over 2, up 3 over 2, then you can go down 3, left 2. And because this says y is less than or equal to, we're going to have a solid line that passes through those points. So our boundary line looks like this. After that, since it says y is less than negative 2 plus 3 halves x, we know that we're going to shade below. And we know that because remember we said when we have something that says less than, that starts with the same letter as lower than or below. So that is our shortcut way of figuring out what to pick. The other way to figure out where you should shade, if you don't remember that shortcut, is to pick, in this case, the point 0, 0 right here, and you test that. So if we tested that, we'd have 0 is less than or equal to negative 2 plus 3 halves times 0. That cancels out, and you have 0 is less than or equal to negative 2, which is false. So that right there is not one of our solutions, so therefore we shade underneath the line in the opposite half of the plane. Now, the next graph we have is y is greater than 1 minus x. And so we'll draw this in purple. We have our y-intercept of 1, and then our slope is going to be negative 1. So we go down 1 over 1, down 1 over 1, and so forth. And you can go up 1, left 1, up 1, left 1. And this is going to be a dotted line because it has a greater than sign and there is no equal to. So we have our line that looks like this. So we're going to draw our arrows onto this line. So like that. And this says y is greater than 1 minus x. So we're going to shade above this line. And what you see is that there is a region that is darker than the other two regions, where the shading, the purple shading and the blue shading overlap. So what that tells us is that the solutions for this system of inequalities is going to fall in this region over here, okay? And so what that means is this: if you pick a point that's in this region, let's say 5, 2, and you plug it into each of these inequalities, you would have 2 is less than or equal to negative 2 plus 3 halves times 5, which will give you 2 is less than or equal to negative 2 plus 7.5, which gives you 2 is less than or equal to, that'd be 5.5, which is true. So since that's true, we check the other one. We plug that into the second inequality. We have 2 is greater than 1 minus 5. 2 is greater than negative 4. That is also true. So we know that this point is in fact a solution for this system of inequalities. And that goes for any point that falls in this region. You could pick this point, you could pick this point, you could pick this point. All of these points that fall in this region that is shaded twice, once for each inequality, are solutions. So the solution for this is going to be this set of ordered pairs in this region. Now, one way that you can explain to someone where the regions are is you can number them. You can say this is region 1, region 2, region 3, and region 4. And then you can say that your solutions fall in region 2. So that's a quick way to just sort of visually show and tell someone that you know where your solutions are. Now we're going to take a look at this word problem. So it says a cereal company is including a chance to win a $1,000 scholarship in each box of cereal. In this promotional campaign, it will give away one scholarship each month, regardless of the number of boxes sold. The cereal is priced differently at various locations, so the profit from a single box is between 0.47 cents or 47 cents and $1.10. So if we want to write a system of inequalities, first we should identify what our variables are. X is going to equal the number of boxes sold, and Y will represent the profit. So first of all, we need to figure out what our initial value is, our starting point, our y-intercept. And for each of these, the y-intercept is going to be this 1,000, but it's going to be a negative 1,000 because they are giving away $1,000 as a scholarship. So they're starting $1,000 sort of in the hole. So the first inequality that's going to be in this system of inequalities is y is greater than or equal to negative 1,000 plus 0.47 times x. And the reason it's going to be plus 0.47x, or the reason it's going to be greater than or equal to this equation is because that 0.47 is the minimum amount that they're going to make. Then the second system of, inequality that we're going to have is y is less than or equal to negative 1,000 plus $1.10 times x. Now, what we're going to do is we're going to graph each of these. Now, instead of graphing these by hand, we're going to use Desmos. So we jump over here to Desmos, and our inequalities are y is less than or greater than or equal to negative 1,000 plus 0.47x. And then our second inequality is y is less than or equal to negative 1,000 plus 1.10x. And then, as you can see, we probably need to zoom out because our y-intercepts are at negative 1,000. So let's zoom out. We'll change our x-axis. We're just going to change everything. Actually, we'll go negative 1,000. We'll go to 5,000 on our x-axis. We'll count by 1,000s. And then on our y-axis, we'll go from negative 1,000 to 5,000. And we'll count by 1,000s again. So we have our system of equations here. All right. So as you can see, it is on Desmos very easy to see where your equation, or where your equations, your inequalities, where the shadings overlap. So I'm going to take a picture of this, jump back over to the notes, and let's see, can I just drag this in here? Nope. So we're going to add from the photo library. We'll add this in here. So here's our graph. So you can go ahead and graph that as well. And what we can look at here is now we can start figuring out what are some possible combinations for this cereal company to, what are some possible combinations of boxes that they can sell and profit that they can make. So if we look at this, we just take one look, we can see that, remember, all the points that fall in this region in here, where everything's shaded twice, those are solutions. So if we look at this, we can see that 1,000, 2,000. So the point 1,000, 2,000, this would mean that they sell 1,000 boxes for $2,000 profit. This value, this coordinate, this ordered pair, is not a solution. Okay, we know it's not a solution because it does not fall inside of this darker region that is shaded twice, once for each equation, or once for each inequality. Now, if you look at letter C, it says, is it possible to sell 3,000 boxes and make a profit of $1,000? That means, is the point 3,000, 1,000 inside of our solution region? And if you look at this, 3,000, 1,000 is right there. It is inside the solution region. So because 3,000, 1,000 is inside the solution region, the answer would be yes, it is possible to sell 3,000 boxes for a $1,000 profit. Now, what you'll see in some of the problems on your homework is that with enough constraints, the solution to a system of inequalities might resemble a geometric shape or polygon. But what you need to understand is that no matter how small the region, there are infinitely many points that satisfy this system. So we can't just say that this point, and this point are your only solutions. No matter how small your region is, even if it is a region where it is boxed off like this, where you have, let's say you have this line right here, this line right here, and then another line that goes like this, and that this is your region of solutions, there are still infinitely many solutions. Okay? Now, one thing to make note of is if you look back up in example B, it is not possible to sell partial boxes of cereal. So really the only solutions that you can have are solutions that are whole number x coordinates as your answer. Now, one other important thing, regardless of what type of problem you're working on, is that you need to make sure that every solution makes sense for your problem. Now, looking at the summary questions, it says, what is a solution to a system of inequalities? A solution to a system of inequalities is the set of ordered pairs that satisfy one or two or more inequalities. And finally, how can you estimate solutions to a system of inequality? You look inside the region of solutions. So what we're going to do two more examples. In the first example, it says determine whether each point is a solution for this system of inequalities. Whenever you want to determine if a point is a solution, you're just going to plug that point into the two equations. So if we look at this first one, we'd have 0 is less than or equal to 1. That's true. And if you plug 0 is greater than 1 minus 2 times 1, that'd be 0 is greater than 1 minus 2, which is negative 1. That's also true. So that is a solution to this system of inequalities. If we check the second point, we'd have 1 is less than or equal to 0. That is false. So this is not a solution to this system of inequalities. Finally, we look at this example that has both of the inequalities written in standard form already. So we have a y-intercept of 1 and then a slope of positive 1. So our line will look like this. We'll go like so. It is going to be a solid line because it is greater than or equal to. And then to figure out which side we shade on, we can test the point 0, 0. 0 is greater than 0 plus 1. 0 is greater than or equal to 1. That is false. That means 0, 0 is not in our solution. Therefore, we're going to shade up here. Then we'll graph our other equation, which is going to be a y-intercept of 1. And then a slope of negative 1, so it's going to look like this. And we're going to have to redo that because it does say less than, so we need to make sure that our line is dashed and not solid. So we're going to, again, it's going to look like this, like so. And then we're going to shade where it's less than. So again, less than, you can check 0, 0. So 0 is less than negative 0 plus 1. 0 is less than 1, which is true. So since 0, 0 is one of my solutions, we shade in here. And then you can see that your solution is, your solutions fall in this region over here that I'm highlighting in yellow. So that is where your solutions would lie. So now you can go ahead and begin working on your homework. If you have any questions, message me on Remind, email me, or feel free to ask the next day in class.